Okay, so this is going through the higher specimen paper, the new higher, and it's paper 2. Starting with question 1. So we have a square-based pyramid. We've been told that each side is 60 units and that OA and OC are lying on the x and the y axis respectively. We've been told the coordinates of D, and we have been told that E is the midpoint of BD and F divides AB at the ratio 2:1. Right, so going through this, we can draw on the diagram. If you're not got a paper that you can draw on, having a sketch is going to be really helpful. So we know that D is 30, 30, 80. Okay, we know that the origin is at 0, 0, 0. We know the sides are 60 units long. So A is 60 units along, and then it's going to be 0 and 0 because there's no x, there's only the x, there's no y or z. C, we know that point is going to be 0, 60, 0, because we've gone 60 along there, but nothing else has changed. And then B, we know that is going to be 60, 60, 0. Right, so we can get going with finding our answers. So now we've got those points, we can get going with finding the parts of the question. So we need to find E and F. E is the midpoint of B and D. So that means each of the coordinates are going to be halfway in between. So for E, if we look at our x coordinates, so the E has got to be halfway between the x coordinates. So we've got 30 and we've got 60, so halfway in between is going to be 45. If we look at the y coordinates, halfway between the 60 and the 30, so that's going to be 45 again. And then halfway between the 0 and the 80 is going to be 40. And then for our F, we've been told that the ratio it cuts it at is 2:1. So we know that this is 2 times this bit, so that's the 2, that's the 1. So the first coordinate, the x coordinate, is not going to change, it's still on that line. Our y coordinate is the one that we're going to have to worry about. So we need to find what is 2/3 of the way between 0 and 60, which is 40. And then our z is still going to be 0. Okay, so part B. We need to calculate ED, and then it's a dot product with EF. So we need to find those vectors first. So ED is going to be D take away E. And we know that D is 30, 30, 80, and E is 45, 45, and 40. So that means the ED is going to be 30 take away 45, so that's minus 15. We have 30 take away 45 again, so minus 15, and then we've got 80 take away 40, so that's 40. We then need to find EF, which is going to be F take away E, and F is 60, 40, 0, take away E, which is 45, 45, 40. So we're going to have 60 take away 45, which is 15, 40 take away 45, which is minus 5, and then 0 take away 40, which is minus 40. Okay, so to do this, we're doing the dot product, which is where we do x1, x2 plus y1, y2 plus z1, z2. So that's going to be minus 15 times 15 plus minus 15 times minus 5 plus 40 times minus 40. So we do that, we get negative 225 when we do 15 times minus 15. 15 times negative 5, or negative 15 times negative 5 is 75. And then we've got 40 times minus 40, which is minus 1600. So when we put them all together, we get minus 1750. So, for part C, we've been told to hence or otherwise calculate the size of the angle DEF. So this is where it comes in using information from our formula sheet. So what we found in part B is the scalar product, and if we look at our formula sheet at the start, which is where we got the formula from there, we have A, B equal to the magnitude of A times the magnitude of B times the cos of the angle. So we've got the dot product. We can find the magnitudes of A and B, or the magnitude of ED and EF in this case, and we can use that to find our angle. So we rearrange this and kind of put in our new things. So we have ED scalar product with EF is equal to the magnitude of ED times the magnitude of EF, all times by the cos of that angle, which is angle DEF. So we'll put theta equals DEF. And then we can rearrange, so we have cos of that angle. It's going to be ED dot product with EF divided by the magnitude of ED times the magnitude of EF. Okay, so we will find the magnitudes. So to find the magnitude of ED, this is kind of like related to Pythagoras. So it's going to be the square root of minus 15 squared plus minus 15 squared plus 40 squared. And that gives us, it's the square root of 2050. We have EF now. There's no point in putting that in, getting a decimal, because that just gives us rounding errors. We've got the square root of 15 squared plus minus 5 squared plus minus 40 squared. And that gives us the square root of 1850. And again, might as well leave it like that, don't want any rounding errors. So we can substitute in. So we get on here negative 1750 divided by the square root of 2050 times by the square root of 1850. So we're going to be putting this into our calculators. So we do theta equals cos to the minus 1 of all of this, so the negative 1750 over the square root of 2050 times by the square root of 1850, which gives us an answer of 153.977, and that keeps going, and then we can round that and get 154 degrees. Okay, so this question, the marks you get 1 for E, 1 for F. You get a point for finding the vectors ED and EF, and then you get 1 for the correct calculation of the scalar product. You get a mark for knowing to use the angle DEF, and using the formula. So here, knowing that that's what you've got to use. You get 1 for finding the magnitude of ED, 1 for finding the magnitude of EF, and then 1 for your final answer there. So that's a big question worth 8 marks. Right, so question 2. It's a really long wordy question, but don't be too put off by it. When we've found through the words, we can see here that we've got the UN plus 1 equals A UN plus B. So that means that this is, in fact, a recurrence relation question. And those are fine. So, part A, we have to use the information above to find the values of A and B. So we've got to look in here and decipher what we've got. So, If we're doing that, we look and we have, so the first number we come across, initially the reserve population of the mammal was 2,000. So that's our initial, so that is our U0, so our very first time, and that's going to be 2,000. And then we've got our next one. So this is by the end of the first year there were 2,500. So that's going to be our U1, which is 2,500. And then we've got our last one, which is our 2,980. And that is our U2, because that's at the end of the second year. So we've got 2,980. So we can use these and we can set up our equations. So we have, so our first one would be that U1 is equal to A U0 plus B. So if we put in our numbers, we get 2,500 is equal to 2,000 A plus B. And then we're going to have U2 is equal to A U1 plus B. So we're going to get that 2,980 is equal to 2,500 A plus B. So we've got simultaneous equations now because we've got two equations and two unknowns. We can place the second one kind of underneath, and then we can take them away from each other, and that'll give us our value for our A. So we subtract them, and then we're going to get 480 is equal to 500A. So A is 480 divided by 500, which is 0.96. Then we can substitute that into the first one to find our B. So if we use our first one, we have 2,500 is equal to 2,000 times 0.96 plus B. So B is going to be that 2,500. And then we're going to take away 1,920, and that's the 2,000 times 0.96. And that gives us an answer of 580. Right, so we've got that part, so we have to go B. We've been told, will it stabilize at over 13,000? So this is asking us, it's a limit question. So we need to know our formula for our limit. So for part B, the limit is B over 1 minus A. And because the fact that A is between 1 and -1, that means there is a limit. So we'll be fine. So we're going to put our numbers in. So we're going to have B, which is 580, over 1 minus 0.96. We put that in and we get 14,500. So the question is saying that conservation measures will end if the population stabilizes at over 13,000. And that's what we've got. So we need to write a sentence to justify our answer. So that means we need to write a sentence. So our sentence could be something like, yes, they will be able to end the measures because the population will stabilize. Or the population stabilizes at 1,000 or 14,500 even, and 14,500 is greater than 13,000. Okay, that's all we need for question 2. But first, going over, let's look over the marks. So you get a mark for setting up your first equation. You get a mark for setting up your second equation. You get a mark for solving for one variable, so getting that A is 0.96. And you get a mark for getting your second variable, so that B is 580. And then we get, for part B, you get a mark for knowing that you're doing a limit calculation, 1 for finding the limit, and then 1 for your conclusion. Okay, question 3. We've got this graph and we've been asked to find the values of p and q for part A, where we've got f of x is equal to x minus p, and x minus q squared. Okay, so this is knowing a bit about our graphs. So we know that our roots, if we set it equal to 0, and our roots are where it crosses the axis. So this first x is this root here. And then here we're crossing, so it is not a repeated root, so that's where our p is going to be. So it crosses at 1, so we know that p has got to be 1. So p equals 1. And then we've got our second root here, so that is a repeated root because it's just crossing, it's not crossing the axis, it's just touching it. So that's got to be our q. So we know that q has got to be 4. So we've been asked to find the tangent to the curve when x equals 1. So to find the tangent to the curve we need the gradient. To find the gradient we need to differentiate. Because if we differentiate a function, then we can set it and we can get our gradient. So we need to first take our equation and put in our values. So we've got x minus 1, and then we've got x minus 4 squared. And now to differentiate, we can't differentiate like that, we need to multiply this all out. So if we multiply out our first bit, we're going to get x squared minus x, and then we can multiply out our square bracket really easily, so we get x squared, and then we get minus 4x, so minus 8x, and then we're going to get plus 16, and then we multiply this out, so we're going to get x to the power of 4 minus 8x cubed plus 16x squared minus x cubed plus 8x squared minus 16x. And then we can get that all together, and so we're going to get x to the power of 4 minus 9x cubed plus 16 add 8, so 24x squared, and then minus 16x. So that is our f of x. So we now need to differentiate that, so we're finding our f dash of x. So we reduce the power and we multiply it by the original one. So we're going to get 4x cubed. The next one, we multiply it by the original power, so that 9 would become 27, and then the x squared becomes x squared. And then we're going to have 48, and the x will become just an x, and then the next one, so the negative 16x, the x will become x0, which is just 1, so we get minus 16. So now, when x is 1, we need to find what f dash of x is, so it's f dash of 1. So we get 4 times 1 cubed minus 27 times 1 squared plus 48 times 1 minus 16. And when we do all that calculation using our calculator, we get that it's 9. So that's our gradient of that line. We know the gradient and we know where it intercepts the x-axis. So we can use that into our equation. So we have y minus b equals m of x minus a. So we have that coordinate on it. So we know we have the coordinate 1, 0. And when we put that in, so we're going to get y, b is that a is there. So y, and then 9, and then we're going to have x minus 1. And that's us. So for this question, the marks, you get 1 mark for p, 1 mark for q. You get 1 mark for expanding your brackets, so all the way, it's all that much working until you get there. 1 for differentiating correctly, 1 for calculating the gradient, and then 1 for substituting the gradient and the point into the equation of the line. Okay, so we have a log question. So we've got part A. We've been told to express y equals log to the base 4 of 2x in the form y equals log to the base 4 of x plus k. So, our laws of logarithms. We know that if we have any log, so I'll just do log and then we've got to the ab, that's the same as the log of a plus the log of b. So we can split our log up. So here we can say that it's equal to log to the base 4 of 2 plus log to the base 4 of x. And then if we use our calculators, we can find that log to the base 4 of 2 is a half plus log to the base 4 of x. So then it says that we have to clearly state the value of k, so we need to write that k is equal to a half. Okay, so for part B, we've been asked to describe the relationship between the graphs of y equals log to the base 4 of 2x and y equals log to the base 4 of x. Right, so we know that plus a half, once we've rearranged, means that that's moving the graph up by a half. So that's what we need to write. So we have that y equals log to the base 4 of 2x is y to the base log of 4x that has been moved up by a half. Right, so we've got C, so we have to determine the coordinates of the point where the graph y equals log to the base 4 of 2x intersects the x-axis. So when it intersects the x-axis, that means that y is 0. So we have to set y equal to 0. And we have 0 is equal to log to the base 4 of 2x. Okay, and we can rearrange so we have our rules, and we know that if we have b to the y equals x, we also have log to the base b of x equals y. So we can kind of rearrange a little bit using those two. So that's going to give us, our b is our 4, so we get 4 to the power of 0 is equal to 2x. So then we know that anything to the power of 0 is 1, so we get 1 is equal to 2x, so that means x has got to be equal to a half. Okay, so the marks for this part of the question come for knowing to split up the log like that and then for getting your k as a half. You get 1 for a valid description of what's happened to your graph. You get 1 for equating to 0 and then 1 for getting your x. Okay, so for part D we have to sketch and annotate the graph of y is the inverse function of x. And we know that f of x equals log to the base 4 of 2x. So my first thing would be to have a little think about what the graph would look like originally. So before we do the inverse, what the graph is going to look like. So it's a log graph, so it's going to come up like this and then it's going to go along like that. So the points that we know on this graph, for part C we found out that it intersects the x-axis at a half. Okay, if we just had a normal log graph, so log to the base 4 of x, we would know that it would intersect at 1. And in part B we got told to describe what happens between the graphs. So we know that it's been moved up by a half. So we know that at 1 that has been moved up by a half. So we have there 1 and a half. So they're the 2 points we know about. So now we can go about drawing our inverse function. So our inverse function of a graph, what that means is that we're reflecting it in the line y equals x. So draw our line of y equals x. Okay, and we've got to sketch our graph, so we know that it's going to go along here, and then up, and off, up towards infinity. So we have to mark, it said to sketch and annotate, so we need to mark some points on our graph, so we can mark the same 2 points. Because it's been reflected, this is still going to be the half. We know that at 1, that is going to have gone across a half and up 1, because what we're doing is we're flipping the coordinates, so the x becomes the y and the y becomes the x. So your points here for this question come from knowing that you're reflecting in y equals x, 1 for having the correct shape of your graph, and then 1 for annotating your graph. And that's your 3 points for that question. Okay, so question 5, we have to find the equation of the perpendicular bisector of AB. So we have to find the midpoint. So for me, personally, I find the easiest way to find the midpoint of something is using the stepping out method. So we've got -1, -1, and we have 7, 3. So we know that point there, we kind of need to find to split it into 2. So here we're going from -1 to 7, so we know that in the x direction we have moved 8. So that means each part is going to have to be 4. So we know that our x coordinate is going to have to be 3. And then we're going from -1 up to 3, so that's 4, so we know that each of these is going to have to be 2. So we know that our midpoint is going to be 3, 1. So now we've got that, we need to find the gradient of that first line, so the line AB. So we know that m is equal to y2 minus y1 over x2 minus x1, and we've got -1, -1, and 7, 3. So that's going to be our x1, y1, x2, y2. So we're going to have 3 take away -1 over 7 take away -1. So that gives us 4 over 8, which is a half. So that's the m of AB. Okay, so we know that the m of the perpendicular bisector, so if we've got a line perpendicular and we times that by MAB, that is going to be equal to -1. So that means the gradient of the perpendicular line is got to be -2. And then we can put that into our equation because we've got the point, midpoint, and we've got the gradient. So we're going to have y minus 1 is equal to -2 x minus 3. Right, so part B, we've been told that CB is parallel to the x-axis, so this here is parallel. Okay, so we have to find the equation of the circle that passes through A and B with centre C. So we're just finding the equation of the circle that they've got drawn there. So we know there that for C we need the coordinate of our circle to use our circle formulas, and we know that the y coordinate, because it's parallel, it's got to be along the same y coordinate as B, so we know that's 3. And we also know that the perpendicular bisector is got to go through the centre of the circle, because any chord, the perpendicular bisector, goes through the centre. So we can put our value of y equals 3 into our equation. So we get 3 minus 1 equals -2 x minus 3. And then, so we're getting 2 is equal to -2x plus 6. So we're going to get 2x is equal to 4. So x is equal to 2. So we now have the centre, and we know that it's 2, 3. So I'll put that in there. And we know that B is 7, 3. So we know that this is the radius, so we know that's got to be a length of 5. So for our circle, we know that it's x minus a squared plus y minus b squared equals r squared. So we can substitute in, we have our a and our b, so we're going to have x minus 2 squared plus y minus 3 squared, and you need to remember to square the r, so that's going to be 25. Right, so the points for this question are for calculating the midpoint, so it doesn't matter which way you use, it's fine. You get 1 for calculating the gradient of AB, 1 for the gradient of the perpendicular bisector, and 1 for substituting in to the equation of the line. And then for part B, you get 1 point for knowing to use the 3, so substituting in 3 into here, 1 for finding x equals 2, 1 for knowing that the r is 5, and then you get 1 for your equation. Right, so question 6. So we've got here, we know that we've got points A, B, C and D, and we've been told that AB is perpendicular to CD. So we know that if they're perpendicular, the scalar product is equal to 0. So the scalar product, there's two different ways of doing it. There's two formulas that you've got at the front, and you can use the second one. So we need to say that, so we can write down that CD, the cross product with AB, is equal to 0 as they're perpendicular. Right, so we have to find CD. So CD is equal to D take away C, which is x minus 2, 2, take away 4, 1, 3. So we're going to get x minus 4 at the top. We've got minus 2 take away 1, so we're going to get minus 3. And we've got 2 take away 3, so we have minus 1. And we've got to find AB, which is B minus A, which is going to be 5 minus 1, 2, take away 0, 9, 7. So we're going to get 5, we are going to get minus 10, and we are going to get minus 5. So we're going to use the formula from the front of our papers, which tells us that the scalar product, so the scalar product of A and B, is equal to A1, B1 plus A2, B2 plus A3, B3. But we also know that the scalar product is 0 because they are perpendicular. So we're going to have 0 is equal to x minus 4 times by 5 plus, and then we're going to have minus 3 times minus 10, and we're going to have plus minus 1 times minus 5. So when we multiply that out, we still have 0, so that's 5x minus 20, and then we're going to have plus 30, and then we're going to have plus 5. So we have 0 is equal to 5x, then we've got minus 20 plus 30, so that's 10, plus another 5, plus 15. So we've got 5x is equal to negative 15, so x must be equal to minus 3. So the points and the marks for this question come for knowing that because they're perpendicular, they're equal to 0. You get 1 for finding CD, 1 for finding AB, 1 for correct substitution, so this line here, and then you get 1 for finding that x is 3. Okay, so we're on to question 7. We've been told that P of t is equal to 30 e to the t minus 2. And we've been given two statements and we have to say whether or not they are true or false. So, if we look at statement A, it says that P of 0 is 30. So we just put this in. So if we look at statement A, so if we've got P of 0, we know that that is going to be 30 e to the 0 minus 2, so the minus 2. We can put that into our calculators and we get that is equal to 4.06. Okay, so we can make a little statement there. So statement A is false as P of 0 does not equal 30. Okay, and then on to statement B. So we've been told that when P of t is equal to 30, the only possible value of t is 1.3 to 1 decimal place. So we have P of t, and we've got that that's equal to 15. So if we set that, we get 15 is equal to 30 e to the t minus 2. Divide both sides by 30 and we get a half is equal to e to the t minus 2. And then we can take the natural log of both sides. So we get the natural log of a half is equal to the natural log of e to the t minus 2. If we've got anything raised to a power, we know that that can come down to the front. So we have log to the base e of a half is equal to t minus 2 times log to the base of e, because that's one of our log rules. We know if we've got a power, then it comes down and multiplies out the front. So we're going to get log to the base e of a half is equal to t minus 2. So we have t is equal to log of a half plus 2. That's happened in this line here because log, if the base is the same as what you've got here, it just becomes 1. And we get that t is equal to 1.3 to 1 decimal place. So then we can say that statement B is true as t must equal 1.3. Right, so the marks for this question, you get 1 for finding the value of p to 0. You get 1 for having a correct statement, but you need a valid reason. Okay, so the fact that we've written p to 0 is not equal 30, that's our reason. For statement B, you get 1 for setting it equal to 15. You get 1 for getting log to the base e of a half equals log to the base e of t to the power of t minus 2. And then you get 1 for completing straight to the end, and then 1 for your statement. Right, so for question 9, we've been given a design for a grain container is the shape of a cylinder with a hemispherical roof and a flat circular base. The radius of the cylinder is r meters and the height is h. It tells you the volume of the cylindrical part, which is 100 cubic meters. And it says, given that the curved surface area of the hemisphere is 2 pi r, show that the surface area of metal needed to build a grain container is given by A equals 200 over r plus 3 pi r squared. Right, so we need to figure out the surface area. So the bottom, we've got the circle, which has got a radius of r. And we know that the area of a circle equals pi r squared. Okay, and then if we think about the cylinder, when we take the metal needed, it's going to be a rectangle. And we've got the height, and then we also need the length. And that is the circumference of the circle. So that's either going to be pi d, or if we think about our equation, it's only talking in terms of the radius. And we know the diameter is 2 times the radius, so it's going to be 2 pi r. Okay, we don't have h, so we're going to need to find a value for h. We've been given the volume, and we know the volume of a cylinder is pi r squared h, because it's the area of the bottom times by the height. And so we can put in 100 for the volume equals pi r squared h. And we can rearrange, so we get h is 100 divided by pi r squared. So we can then find the area of the rectangle, or the area that you need for the outside of the cylinder. So the area of the rectangle is going to be, it's just length times breadth, which is 2 pi r times by 100 over pi r squared. So the pi's are going to cancel out. The r on the top is going to cancel out, and the squared on the bottom. So we're going to get 2 times 100, so we're going to get 200 over r for the area of the rectangle. So then we just need to add them all together. So the area is going to be that 200 over r, which is for the rectangle, plus the pi r squared of the bottom, plus the 2 pi r squared for the hemisphere, which gives us the 200 over r plus 3 pi r squared that we were looking for. Right, so that's part A done. So for part B, we've been asked to determine the value of r, which minimizes the amount of metal needed to build a container. Okay, so the first thing we need to do is take our A, and we have 200 over r plus 3 pi r squared. We need to differentiate that with respect to r. Okay, so before we actually can do that, we need to kind of rearrange this a bit. So we're going to get 200 r to the minus 1 plus 3 pi r squared. Okay, so starting differentiation, we multiply by the power, and then we subtract 1 from the power, so that will become minus 2. And then we multiply by the power, so we're going to have 2 times the 3, so we get 6. And then we're going to have pi, and then the r, so that will come down, so we're just going to get that. Right, so we know that to minimize something, we want to set it equal to 0, because that's the stationary points, because when you differentiate, that is giving you the gradient, and at the stationary points, the gradient is 0. So here we're going to have minus 200 over r squared, once we've kind of rearranged a bit, plus 6 pi r equals 0. Right, so solving this, if we add 200 over r squared to each side, and that's going to be equal to 6 pi r, times both sides by r squared, so we get 200 is equal to 6 pi r cubed. And then we're going to have r cubed is equal to 200 divided by 6 pi. So therefore r is going to be the cube root of 200 over 6 pi, which is 2.20 meters. Okay, so we need to check that this is in fact a minimum. So we're going to do this using a nature table. So we're going to find the values for 2.2. We're going to find it slightly higher than 2.2, so 2.3, and then we are going to find it at 2.1. So when we put 2.1 into our equation, once we've differentiated it, we get negative, and then when we put 2.3 in, we get a positive, and then we put that in, it's a 0. So that is showing us that this is in fact a minimum. And that is us done for this question, so just going over where the marks are allocated for this one. So for the first question, for the first part of the question, you got the mark for setting the volume equal to 0, 1 for finding the fact that h was 100 over pi r squared, and then 1 for completing the area evaluation. And then for part B, you got 1 for knowing and starting to differentiate. You got 1 for completing the differentiation. You got 1 for knowing to set it equal to 0. 1 for finding r. And 1 for justifying the nature. And then the last thing you need to do is interpreting a result. So here we need to put that in. So the minimum amount of metal is when the radius is 2.2. And that gets you the last mark. And that is question 8. Right, so on to question 9. We've been asked to find the shaded area. Okay, so this is an integration question to find the area under a graph. So we're going to have to integrate between 0 and the 2 over 3 pi the sine of 3/4 x minus 3/2 pi. And we're going to have to subtract between 0 and pi over 4 the cos of 2x, both with respect to x. So it needs to be a little dx in there. Right, the reason that we're doing that is because this line here, so this graph, this function, is on the top. So that's the one that's going to have to go first. And we're integrating between 0, so this axis, and where it stops. We have to subtract the area made by this curve. So we're subtracting it, and that goes between 0 and the pi over 4. Right, so getting into our integration, so this is our area. Okay, so we start off our integration, and we know that sine integrates to negative cos. So we're going to have negative cos, and then we have our brackets, which stays the same. So we have 3/4 x minus 3 over 2 pi. And then we have to divide by the differential of the bracket. So if we differentiated that bracket, we would get 3/4. So when we divide by 3/4, we get 4/3. And that's us done. And then our second one, when we integrate cos, we get sine. And again, the bracket stays the same. When we differentiate 2x, we get 2. So we have to divide by that, so we get a half. And then obviously our limits stay the same. So now it's a case of substituting in our limits. So we're going to have a big bracket first, and then we're going to have minus 4/3 cos of 3/4 times by 2/3 pi minus 3 over 2 pi, and then that is going to be subtracting minus 4/3 cos of 3/4 times 0 minus 3 over 2 pi, and then from that we're subtracting a half sine of 2 times pi over 4, and then minus a half sine of 2 times 0. So ran out of space just about, but we managed it. And then we can put that in each individual bit into our calculator. And when we do that, we get 4/3 for the first bracket. For the second bracket, we get 0. And then for the third bit, we get a half. And for the last bit, we get 0 as well. And then when we sort all that out, so 4/3 take away the half, we get 5/6. Okay, so the marks here are for knowing to integrate, for having the correct limits, for correctly integrating the first term, correctly integrating the second one, correctly substituting in your limits, and then for getting to the answer. Okay, so for this one there are quite a few places that you can make little mistakes, so it's just being careful and remembering that you have to, when you're when you're integrating, when you've got sine or cos, and then in your brackets you've not just got the x, that you need to divide by the differential of what's in the brackets. Right, so we're on to question 10, which is the last question of this paper, so we're almost there. Okay, so we've been given two waves. We've been told that they've been added together and they've produced the wave shown. And that it's got the equation y equals k cos of t minus alpha. So when we add them together, so for part A, we're asked to find the values of k and alpha. So we know that sine t plus root 3 cos t is equal to that k cos of t minus alpha. Okay, so we need to expand our k cos of t minus alpha. So quickly, just here, if we have the cos of t minus alpha, we know that from our equation sheet right at the start, if we had an a and a b in there, so I'll just change it quickly. So if we've got the a and b, and we've got, it was a minus, so that is going to give us, we're going to have cos a, cos b, and then it's going to be plus, because with the cos one it changes, and then you're going to have sine a, sine b. So we can expand that second bit over here. So we're going to have k times by the whole lot, so it's going to be cos t cos alpha plus sine t sine alpha. So we have k cos t cos alpha plus k sine t sine alpha. So we know what t is our variable, alpha is a constant. So we know that the signs must be equal, so the constants in front of them. So sine has got a 1, so we know that 1 must be equal to k sine alpha. And our constant in front of our cos t is root 3, so we know root 3 must be equal to k cos alpha. Right, so from there, we can use this to find our values for our k and our alpha. So if we divide these, if we divide the sine by the cos, we get 1 is 1 over root 3 is equal to k sine alpha over k cos alpha. So that gives us k, the k's cancel out, and we just get the tan of alpha is equal to 1 over root 3. So we know there from our exact value triangles where we've got 2, 1 and root 3 that the tan is opposite over adjacent, so it's going to have to be this angle in here, so the opposite over the adjacent. That's 30 degrees if we're using degrees, but we need it in radians, so 30 degrees is in fact pi over 6 radians. So we know that alpha must be pi over 6. Okay, and then we also have to find our value of k. So we know that from this same exact value triangle, we know that 1 equals k sine of alpha. And we know that the sine of pi over 6 is opposite over hypotenuse. So sine alpha is a half. So 1 equals k times a half. So k must be equal to 2. Right. So on to part B. It says it's part C, but it is part B. There's only 2 parts to this question. It's got a bit confused, but that's fine. Okay, so we have been told that point P has a y coordinate of 1.2. So we know y equals 1.2. And we know that y is equal to k cos of t minus alpha. And we know that k is 2, and we know that t alpha is pi over 6. And we know that y is 1.2. So we can go about solving this. So we divide by 2. So when we divide 1.2 by 2, we are going to get 0.6 is equal to cos of t minus pi over 6. So then we know that t minus pi over 6 is equal to cos to the minus 1 of 0.6. And we get that that is going to be 0.927. That is our first value, and we know that our value is in fact in our 4th quadrant because it's over here. That means that we're going to have to find our second value. So we're going to have to take that first one and take it away from 2 pi to get our second value. And we get that that is 5.355, and then it just keeps going. Okay, so we then have to find t, and to do that we have to add pi over 6 to these. We get that this is 1.45, keeps going, but we don't really need that one. We need our second one, which is 5.879, so we're going to round that to 5.88. Right, so then just making sure that we know and we're clear about this, write our coordinate down. So it's going to be 5.88, and then it's going to be 1.2. And that is our coordinate. So the points for this, or the marks for this question, you get 1 for knowing to add the 2 together and set them equal to the k cos of t minus alpha. You get 1 for correctly expanding k cos of t minus alpha. You get a mark for knowing to compare the coefficients, so knowing that because the coefficient of the sine t at the start is 1, then the 1 has to be equal to the k sine alpha, or the equivalent for the causes. You get 1 for interpreting the comparison, so being able to find the values for alpha and k. And then for part B, you get 1 mark for knowing to set it equal to 1.2. You get 1 for rearranging correctly. You get 1 for solving the equation for t minus pi over 6. And then you get 1 for finding the t coordinate of p by interpreting the diagram, so knowing that it's got to be the second value, not the first one. Okay, so that is finished with the higher specimen paper to paper 2. I hope this has been helpful. Let me know in the comments if it has been. Let me know any improvements I could have made. And thank you very much for watching. Any comments would be great. Subscribe. But thank you.